Hey, what's up, guys? This is Chung here again. So let's take a look at another weekly contest problem here. Number 1626, best team with no conflicts. I think this is a very good DP problem. So, okay, you're a manager of a basketball team, blah blah blah, right? And for the upcoming tournament, we can ignore this part basically. The so what's more important is the you have two lists here. So the first one is the score, and the second one is this person, the person's age, right? So the score is the person's score. Okay, so we have for each person, this person have two properties. The first one is the score, and the second one is the age. Okay, and then your goal is to pick up any number of people so that you can who's to form a team, right? Whose team has the maximum score. Okay, but there is like a constraint here. Basically, your team cannot have any conflict, right? So what does a conflict mean? So the conflict exists if a younger player has a strictly higher score than an older player. So which means if in your team you have two players. Player one is younger than than player B, but player player A has higher score than player B. So this is like a conflict. So and you just need to avoid that conflict while still trying to get the highest scores out of everything. Okay. So I mean at the beginning, right? I mean when you guys see like this kind of highest problem, maybe try binary search first. Okay. But for this problem, let's say for the binary search you search this highest score here, right? So if you try to use a binary search, given like given like the highest score, so your condition will be can you form a team with that score, right? Then I mean then you still, right? Basically, even with that score, uh, it doesn't really help. You still need to pick up, loop through all the peoples here, and then you also need to validate this, try to avoid this conflict, right? So I think binary search won't work, and the brute force won't work either because uh, we have like up to 1,000 people. Okay, so with 1,000 people, right, the total combination is 2 to the power. Uh, okay, why this thing doesn't work? Hmm? I'm trying to hold on. So yeah, sorry, for some reason my drawing software did stop working. So and with this 1,000 person, so the total combinations will be like 2 to the power of 1,000, right? Because for each people, we can either pick it or don't pick it. So the total combination is like the 2 to the power of 1,000. Of course, this is a like a no go, right? So and then the only thing left to us is the dynamic programming, right? So but there is like a trick there's a like a tricky thing for this dynamic programming because I think most of you probably knows the DP, right? So let's say we have a DPI here, right? So with DPI here, we have a equals to what? We have a DP, basically max of what? Max of DP DPK, right? Plus the current score, right? The score scores I, right? I mean, this is like the formula, like a very basic formula where the to calculate the current I, you loop through from basically this K is in the range of 0 to I minus 1. Okay, you loop through everything, right? So this is like a similar like a K knapsack, right? Like the knapsack problem. Basically, you loop through everything starting from 0 to I minus 1, and then of course you cannot use any of them. You have to use like you have to check, right? Basically, you need to check with this case index. Uh, we need to make sure there's no conflict with the current I, right? Then you can use this one, right? That's it seems right, but there's a like issue for this, you know. So why is that? I mean, let's say, so I'll give you a very like simple example here. Let's say we have an age here. So we have a, so the first column is age, right? The second column is the score. Okay. So we have a like 2, 7, and then we have a 4, 10, right? And then we have 1, 8. Okay. So and then we have DP, right? So the first one DP is 7, right? So so the DP, this one is 7, right? And how about this one? So this one 4 is older than 2, so which means we can use this, right? Right. So the DP of this one is 17. Okay. So how about this? I mean this one, okay, one is smaller, one is younger than 4, and 8 is smaller than 10. So which means that okay, so this one looks okay. So I'll just use 25, right? Because when you loop through the because but this is not correct, right? Why is that? Because 1 8 and 2 7 is a conflict, right? So this two is a conflict, and this 17, this 17 here, it includes the values coming from 7. Basically, it actually is as if you're drawing a line from 17 to this, right? Which is a conflict. Basically, so that's why you cannot use this DP, right? So I mean, oh, by the way, so we're defining like this DP, like the current to pick the current persons, to pick the current ith person, what's gonna be the highest score, right? That's the definition of our DP. I mean, whenever whenever this happens, right? What I mean is that whenever you're trying to draw an edge, basically, so it's as if you're drawing an edge from this K to I here, right? Whenever you're trying to draw an edge from K to I and the conditions doesn't hold anymore, like for example in this case, right? So then it means that the way you are traversing this list is not correct. Okay, so basically what does it means that you have to somehow, okay, basically it means that you need to sort I mean sort this list in a way so that when you try to draw a line from this K to I, the conditions still hold. In our case, it's guaranteeing that there's no conflict. There's no conflict first between K and I, and also with all the values, with all the values coming that this DPK includes uh, to this I, there's no conflict for all of them, right? Because you know this DPK can come in from a different value, right? So a different like DP, a different DP, basically a DPJ or whatever, right? So we just need to make sure everything that's in that we have seen so far from this path still holds the conditions comparing with the current ice person, right? Right. So to do that, I mean, we just have uh, to sort this thing somehow, right? I mean, the easiest way is we just do a first I'm going to zip it. So to zip these two things together. So as you guys can see here, so I put the ages at the beginning and the scores at the second place. So which means that and then I zip those two lists together and then I convert them into a new list here. And then I'm going to do a sort these things. So when I do the sort here, it means that I sort the ages, right, from the smallest to the biggest ages. And with the same ages, I sort from the smallest score to the biggest score. Okay. So with this sorting, so let's see what changed. Okay, so we have a DP, right? So 0 plus times n here. So now when I try to loop through these things here, right? So and current score, I'm going to, so the current score is data I and the 1, right? So the 1 means that, so, so after zipping, after zip these two lists, we have a new list with tuple, right? So the tuple is the we have age and a score in the tuple. So and the second one in the tuple is our score. So I'm getting the current score of that. And since the definition of the DP here is that we're picking the current person. Okay, it's gonna be the DPI here. To pick the current persons, we need at least we have the current score, right? And then the next question is that to pick the current persons, like can we get any previously calculated sum, right? So basically, it means that we have to loop through everything until I so far, right? And then so now, since we sort by the ages first, right? It means that the ages I, the age j is equal or smaller than the age I, right? So and then so how can we make sure we can use the basically I'm doing this, right? So dpi will equal to the max of the dpj, right? Sorry, dpi, and then comparing with the dpj plus the current score, right? So that's going to be our formula here, right? The transition state transition function here. And so which dpj we can use? We already know that the j is younger, is not older than the I here. So we just need to make sure that the data, right? The data of the j, basically the score of the j is not greater than the current score. And then we can sure that we can use the values from dpj, right? So why is that? Because as you guys can see, of the first one is the the ages that have we have currently traversed until the DPI here is always increasing, right? It's always increasing, and the scores in this in this path is also basically also like a monotonic increasing, right? Not going to be decreasing, so that so the condition, there's no conflict. The condition still holds. Okay, and then later on, so then we can simply do a return the max of dp. So why we don't return the dp n minus one? Because I mean uh we don't have to pick the last one. Basically, the definition of our dp is like we're picking the current I, right? But it we could pick any persons. Basically, the picking process can stop at any of the person. I mean, we can only pick the first two persons, right? And we don't pick the last one. So that's why we need to get the maximum out of all the DP values here. Cool. So let me try to run the code. Uh, oh, sorry. Okay, I haven't defined these values here. Scores. Okay. Oh, current score. Sorry. All right. So submit. Cool. So it's accepted. I mean, uh, so I mean, space and time complexity should be pretty straightforward, right? So the time complexity is the we have a nested for loop here, right? So it's definitely the O(n) square, right? And the space complexity is the oh, and okay, we have a sort here, but you know it's n squared is like the it's lower, it's greater than the n log n, right? So the still it's n o n square. So space complexity is like this, right? So it's the it's O of n, right? Cool. I mean, so this problem, you know, the I think the most important thing uh, to to learn from this problem is that you know the uh, whenever you're trying to use this template, right? I mean to get the DPI from the previously state, right? Be sure, you know, be sure to check if the current condition still holds, right? Without doing any of the sortings. In this case, it's the of course, you know, it also depends on like if you can like change the ordering of the input. If you cannot change it, then probably it means that the it's already sorted in a way, right? So that you can just use it. But for this problem, you know, since you can pick any persons in any of the order, right? And so it means that if this state transition function state doesn't hold after you're doing this kind of calculations here, it means that you have to uh, you have to sort this list so that you can make sure the condition still holds right here. Mm, okay, I think that's what I'm that's what currently I can think of in uh, what I have in my mind. I don't know if I have explained it clearly enough, and let me know, guys. If you have any questions, just leave me a comment. I'll definitely reply to your comment. So other than that, thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.